Hello. Really glad to be here. Like we already talked about, I'm already messing it up. Sorry about that. So, like was mentioned, I wrote a book recently on pandas. It covers a wide range of topics, but kind of what I want to do here is talk about one specific topic. It's covered in one section of the book, and that's indexes. I feel that indexes are maybe an intermediate to advanced feature of pandas. They don't get a lot of use. They're certainly not necessary, but I think once you start to use indexes with pandas, you can really see a lot more of the power that it provides in terms of data manipulation. I'm sure everybody here has some interest in data analysis or working with data in general, and data manipulation is often, as most people know, the least fun part of that job. And pandas, because of that, learning pandas and knowing a lot about pandas can allow you to do that part of your job faster. So indexes even accelerate that. So that's why I wanted to take today's presentation and talk about indexes in particular. So we had a quick, short resume, and so I kind of don't want to talk about kind of what I've done so much in general, but do want to talk a little bit about my experience with pandas. So like was mentioned, I have mainly a background, at least educationally, in accounting and finance. And when pandas was getting started, it was really for its main use case was financial time series data, which I thought was great, and I use it quite a bit. I think I've been using it since maybe the .6 release. So been using it quite often, and I really enjoy it. I think pandas is probably the number one reason why Python is starting to eclipse some of the other languages out there that may be specific to data analysis, such as R. So, pandas is great, and I've been using it. I think it probably gets a lot of use as an ad hoc data analysis tool, but I think it also should be given some credence as a library that can be used in typical applications, given its speed and given some of its ability to reshape data and do it in a very fast manner. And certainly all of that credit goes to Wes McKinney and those individuals who started Pandas, and Pandas has a great community out there of developers as well. And one thing really quick before we get started, I just want to reiterate the ask for questions. I can talk a lot and run through these slides, but I think it's more valuable for everybody if questions are asked and I respond to questions, and I think it'll make it a much more lively discussion than me trying to predict what you all want to hear about, as opposed to you asking questions and then me talking about what's really of interest. So I guess what's planned to be talked about is this agenda, and I promise this is the last bullets. I kind of want to talk briefly about index information, kind of how I think about indexes, how I think it's useful to think about indexes, and just so we're all on the same page, I want to talk a little bit about creating objects with indexes. So that's hopefully going to cover two primary use cases. You already have an object, like a data frame, but it's indexed in the default manner, so it's just 1 through n, where n is the number of rows. The other situation I want to describe is you have a file or maybe a database or something along those lines, and you're reading that data into Pandas, and as you ingest that data, you're potentially adding indexes to it. Both are good methods, but you're going to find yourself in both situations, so I kind of want to cover that from those two angles. Next, I want to talk about just basic selection of data, which is really powerful, and probably what most of the uses around indexes is once you have an object with indexes, how do I select data? How do I manipulate data with indexes? Then I want to cover special indexes. So the very typical and the very basic index you'll use is, it's really very analogous to an ID in a database, right? So you'll have 1 through n, or you'll have labels maybe stock tickers or something along those lines. But there are kind of special indexes, primarily time indexes, datetime indexes, and hierarchical indexes, which is where you might index something by multiple values. I want to talk a little bit about those, and then finally I want to get into two real quick examples of manipulating objects with indexes. One where we're actually making updates to the object, and another where we're doing a little bit advanced kind of reshaping of the data. So, like I promised, there will be no more bullets involved. I do want to tell everybody that I'm on Python 2.7 and I'm on Pandas .12. Just so some of the things you'll see, if you're maybe using a prior release, may not work. I know that .13 came out recently, and so where there has been some enhancements to some of the features, I'm going to try to call those out, but by no means is it meant to be exhaustive. And the other kind of quick hitters is, this is very typical. If you've worked with Pandas before, you've certainly seen these, but whenever I call Pandas, use PB, and whenever I use NumPy, I'm going to use NP. So, like I said, the first thing I wanted to do was kind of talk about kind of the mental model, so to speak, of indexes. So what we have here is it looks like a Rubik's Cube, but what it really is kind of a three-dimensional object, which is 1 through 27. As you can see, I kind of create this object by creating a list of numbers 1 through 27, and then reshape that into a 3 by 3 by 3 object. And so what this is a panel, and this doesn't get a whole lot of use case in Pandas, I don't find, although it's very valuable. I think typically you'll work with DataFrames, or typically most people work with DataFrames, but panels are very valuable for data analysis to give kind of the my use case for them. So right now I work in media analytics, and you could imagine a situation where you could have different types of media, maybe banner ads, maybe cost per click information, maybe organic search results, and you have some common metric impressions, and you have a time series of those values. And so the individual panels could be the media, and then you could have the value by time. And so that's a really nice way to structure your data, is to use panels. What you'll see here is we kind of have a stack of 3, and so each individual slice then is in a data frame, right? So I've actually want to give, so here we're giving a little bit of a preview to one of the accessor methods of Pandas, and it's the IX method. So this allows you to access values of your object via an index. So this object is very naively indexed as basically 0 through 2, 0 through 2, 0 through 2 being the depth, the width, and the height. So what I have here is I'm showing basically we're selecting the very first panel via the index, which is this first slice. So this is actually really similar. Another kind of way to think about this, if you're familiar with like business intelligence, is you can think of your indexes as dimensions and your values as measures, right? So you have indexes which describe your data. Those are your dimensions, and then you have actual facts about what the data is, and those would be your values. So if you have a BI background, that's a really useful way, in my opinion, to think about these things. And as you can see, via kind of the second chunk of that, where I'm asking for the type, it is a data frame. So if we take a step back, you'll notice that it is it's actually a panel, whereas here it's a data frame. And we can kind of continue to work down the panel and get more detailed as we move along. So we were working with a data frame, and now we're working with a series, which is really series kind of build up into data frames build up into
Hello, Trent. Folks, we're sorry about that here. We're going to try to get Trent back. If you can please just stay tuned for just one moment. We'll have him call back in. Back with us?
I am.
Hi, Trent. All right, folks, we have Trent back with us. He's going to pick up approximately where he left off. And just to let you all know, as the program is continuing here, open your group chat widget. It's that little widget in your widget tray. You can type in questions and any comments that you have. And if you can put a Q in front of your questions, we'll know they're for Trent, and we'll turn the program back to him now. Back to you, Trent.
Okay, yeah, sorry about that. I suppose it wouldn't be a good presentation, or well, I guess you'll be the judge of its quality, but it wouldn't be a presentation without some technical difficulties. So certainly apologize for that. Did see a question come in. Should we follow along in Python during this? I would say that would be a great idea. Kind of transferring what I talk about in the slides through your fingers is a great way to learn this. So I think that's a great question and a great idea. To be completely honest, one of the ways that I initially learned Pandas was there's tutorials that were given at various PyData conferences, and they're online, and just watching those, and as I watch them, type in what I see. So yeah, I think that's a great idea. It's a great question. Highly suggest that. Another question that came through was, does this work well with HTTP data? So I assume you're referring to logs, or I assume the question is going to refer to logs, and so I would say it does. Recently, I want to say maybe in the .10 release or somewhere around there, Pandas added vectorized string functions. So what that really means to you is you can access string methods the same way you would be able to access other methods. So you can imagine a situation naively where you have a list of maybe integers 1 through 10. Each one of those is, kind of a point in the data frame, and you can maybe just, very simply add a number to that, right? But what happened fairly recently is vectorized string functions were added. So maybe you want to parse out your Apache log information, and you want to get, maybe the header information of the browser, or you want other information along those lines. There is I believe it's str after a column name, and then you can have access to like regex methods or like split methods or other string methods that you would have used with normal data. You can actually do those on frames, on data frames or series. So yeah, I think it's a great question, and I haven't used it specifically for Apache log information, but I don't see a reason why you couldn't. Okay, so kind of getting back into this. So we kind of covered at a high level, basically kind of the mental model of how you can start breaking down panels into individual components of what kind of builds up into a data or builds up into a panel, basically the individual items and the series and the data frames and so forth. So what I kind of want to move to now is creating objects with indexes. And so, like I said prior, this is going to kind of cover two things. It's going to cover one, which is I have a brand new object, maybe creating that with like read CSV, which is what I'll talk about, and then we have an object and we want to add an index to it. So very basically, these are the two situations I want to walk through. And to the right, you're going to see the file that I'm using. This is just a very simple, very contrived example where I have date, product, and price. Right. So date is going to be the first of the year through the 3rd of January for each product. I have 3 products, and then I have associated prices with them. The kind of simple way to read that in is to use read CSV, and then there is a method called setIndex. And setIndex is a great method. It's really kind of, it's very simple, but it's good to kind of get in the habit of using it and to add, really what is kind of metadata around the actual data you have. So setIndex, what we're doing here is we're taking those first 2 columns, date and product, and those are going to be our index. And technically, this is now a hierarchical index. I'm going to talk a little bit about more what that means later, but just in terms of this, it is, we have date as the first index, and then we have product as the second. What you can actually do as well, so this is the second part, this df2, that is where we're reading in a file, and we're applying an index to it as it's ingested. And so quite often, and you'll see this, and this is maybe a general practice with pandas. So index calls right there basically takes a 0 and 1, or that's how I'm passing it to designate which columns I want to assign to indexes. Most of the time with methods like this, you can pass either the location of the column that you want to apply as an index, so 0 or 1 in this case, or you can apply the actual names of those columns. So what we could do here is we could pass in date and product, and that would work as well. There's a couple housekeeping things to take care of on the setIndex method as well that don't really talk about, or that don't get shown here but are worth knowing about. In place is what I mentioned in comments right there. What that does is modifies and really updates the data frame or the object as it's as you're setting the index. So instead of setting df1 equal to df1 setIndex, you can just set in place equal to true, and it will update the data frame in place. A couple other things to think about. You can kind of iteratively add indexes to your object. So what you might want to do is maybe you read in date first, right? And so you set index and you only pass it date. Then you have a data frame that has date as the index and and product and price. You can call that again with product as the argument to the setIndex method. However, if you add the append argument, it will then put both of those will become the index, because what setIndex does naively is it's going to overwrite your indexes that exist. So you want to use that to kind of iteratively add things, or not destroy indexes when you add them. So as of this point, without going to the very bottom line of this slide, df1 and df2 are the same object. One thing, though, to be aware of is you can actually swap levels. So from a conceptual point of view with a hierarchical index, levels are basically the order of the hierarchy. So right now, or if I hadn't called swap index, date would be level 0, and product would be level 1. And basically, as you go down the hierarchy, the number of levels increase by 1. So you can kind of go down as far as you want, and each time you go down, the level will increase. And that is, levels are used quite often for reshaping. You might pass a level argument to specify the level that you want. There are some accessor methods that I'll talk about here in a second that actually use level as the argument. So levels don't work, or they work how you would expect them, in the sense that they're zero indexed and they move down the hierarchy. So we've read a file, and now we want to kind of add more structure to it, right? So we can call DF, you can basically call it toPanel, and that will give you a panel object back. And again, we have these axes, right? So we have the items, the major, and the minor axes. So when you read these in, when you read this file in, you can give it more structure. And again, the whole kind of idea behind indexes is giving structure to your data to make it easier to work with. So I would kind of always advocate for adding as much structure as you can to your data, because then it's going to make you working with it in the long run much easier. So one thing I kind of want to point out here is that levels, indexes and axes are very similar conceptually. So just a second ago, showed you a swap level method, df1.swap level. Here I want to show you, something very similar, which is the swap axes. So basically, you can take axes which are different, which are your items, which is the price in this situation, which is the date, or the individual product, and you can modify that so it will align better to what you're trying to do. So here we want to basically swap the axes so it makes a little bit more sense as we see here. So what you probably want is gloves and shoes as your individual items. And so if we think back to the very first slide, the Rubik's Cube example, you probably want your slices to be the individual products. So you want those panes to be the products, and then you want the date running down the side, and then you want your minor axes to be the measure, in this case, which is really the column. And to show you here, this new file actually has price and quantity. So you can have multiple measures, and then they can become multiple columns within the object. Kind of moving along, as you work with panels, panels kind of retain all the access information, even if data isn't present. So you can imagine a situation where I have my data2 CSV file, and in this data file, the 3rd of January is missing, right? So if the 3rd of January is missing, that's going to create NANs. And this is maybe a general Pandas thing. It's one of the things that gets a lot of press for, is its ability to handle missing data. And so if you're missing data, the axes are going to behave kind of as you hope they would. When you call .gloves, it's still going to give you that glove item data frame. It will just have NANs because your date field is an object as well. So here's a great question that came through. This is, why would you want to swap axes? So that's a great question. And hopefully maybe I talked a little bit about it, but just to kind of reiterate the point, it comes down to organizing your data. And if your data comes in and it's not organized in the manner that you would expect to work with it, you want to reshape it prior to going down avenues that would require more work in the long run. So if we go back to the situation here where we just naively turned a data frame into a panel, our major axis is price to price. So what that means is we have a window that only has one panel, and so price then is the major way that panel is indexed, and price isn't an additional piece of information about the data. It's not really metadata. What it is the actual measure that you're interested in potentially doing calculations on, or graphing, or working with in some manner. So the reason you might want to swap an axis is your data is in a bad format initially, and you want to get it into a better format. Okay, so we talked a little bit about indexes being smart and kind of how they can be used with panels. One thing I kind of want to touch on now is index objects as byproducts of other manipulation. So index objects kind of show up, and this is, to be honest, this was one of the main reasons I thought to speak on this about indexes in particular, is that what I found myself doing quite often when I started learning pandas was I would group by something, and then I would re-index it immediately because I had the objects that I grouped on, or the dimensions that I grouped on, would then become indexes, and I wasn't really comfortable working with indexes, so my immediate next step was to just get rid of them. And I kind of knew there had to be a better way. But in this situation, what I do want to talk about is, in what situations are you going to potentially get indexes back, right? So group by is a super common use case. You're going to use it all the time, and just be aware that what it creates as indexed objects is an indexed object, but actually that group object itself has an index. The kind of interesting thing too, though, is if you have indexes, you don't have to get to a unindexed data frame to do group level operations on them. So you can kind of see here we actually can pass level, what I mentioned earlier, to the object or to the group by, and it will group by the same. It'll group by product in the same manner. You'll notice that it's a little bit different, the index order, than the data CSV file. I just want to point that out so there's no confusion. Product is my level 0 index in this situation. So there are a couple other situations that aren't mentioned on the slides that we want to talk about in terms of getting indexed objects back. Pivots. So I think really the first data analysis tool that most people use is Excel, which pivot tables, and I like to bag on Excel as much as the next person, especially coming from a background in finance. But pivot tables are a really useful manner in doing quick data analysis. And so when you actually use the pivot method of Pandas, you will get back an object that is indexed. You can kind of imagine a situation here where I have date, product, and price, and it's coming back as a file, or basically this flat table, but you may want to pivot that in a manner where you have date as the index running across the side, and then product name is the column, so you could have shoes, gloves, and price, and then, shoes, gloves, and pants, and then price would be the value. So there are a couple different situations in which you're going to get back indexed objects, and one of the best ways to start getting more comfortable with indexes is to fight the urge to immediately take that object that you just got back and destroying it by calling reindex. I don't even put reindex in these slides because it's the simplest way to get back to what your comfort zone without indexes, but indexes kind of in the long run are very useful. So the next thing I kind of want to talk about, and this section is going to be fairly quick because I want to talk about this, and then I want to get into the special indexes and talk a little about how those are used to do selection or how selection of objects via indexes work in those special situations. But kind of, to cover the bases, so to speak, there are three main ways of accessing individual items from a data frame or from the objects. You've already seen IX, so that's what I'll talk about here in a sec. But there are two more basic methods, and then one that's not mentioned on the slides that I'll talk about. So loc is, I suppose it's short for location. It is going to take a label, the value of the index, and look for that label and return the value. So you can see here that I created a very simple series, 1 and 2, and then it's indexed by A and a B. So location is going to, if I pass B, it's going to return a 2. Right? So it's going to basically turn the associated value of the index B, which is 2. So that's great. So, but one thing you have to be careful of here is that it is not robust to integer access. So if I have another series here, which we'll call T, and it's indexed with a 2 and a 1, but the actual values are 1 and 2, if you pass 2, you would expect to actually get back a key error because 2 does not exist in its. 2 is a label, but it's not an integer location because it's out of range basically. So you would expect to get an error. Now, that said, one of the changes coming up in the .13 release is that you can set the values on out of range indexes via loc and iloc. So if I wanted to take something that was out of range, maybe call t.loc and then pass it a 3, I could then set that value to be 3 and it wouldn't throw an error. In the version that we're talking through here, the .12 release, that would throw an error. So that's something to be aware of. So moving on to the iloc, which is really integer and position-based labeling. So that works as you would just have a list of 1 through the number of rows, and if you pass it, little n, you get back the associated item. So that is dead simple, and because of its simplicity, I did want to mention that slicing works for selection. So in this situation, we can actually pass. Well, I guess to take a step back, it's really the exact same, or kind of as you would expect integers to work, or excuse me, array access in normal Python to work. It doesn't try to trick you in this case when working with indexes. So you can expect you can pass slices. And I'll actually show in a second when you're working with a DatetimeIndex, you can pass it a slice of dates, and it will work kind of as expected, which is a kind of boon to dealing with time series. And then talking really quickly about the IX method. You'll have to excuse the formatting here, but if you pass it, so to take a step back, IX is really kind of attempts to be a smart combination between loc and iloc. So you can potentially pass it a label, right? So I can pass it an A, and that'll work as expected. You can pass it a 0, so that's an integer, and that'll work as expected. The thing to be careful about, though, is like the third situation where you have a key error, and the reason we get this key error is because T is indexed by integers, and we're passing it an integer, but it expects that to be the value, or it expects 0 to be the actual location or the label, but the label doesn't exist, so you get a key error. And I just had a question come in, so why use indexing methods other than IX? And that's absolutely a fair question. To be honest, in practice, I typically just go straight to IX because I'll often be working with pandas in an interactive session, or I'll be using it where I have a lot of confidence around what I have in terms of what's in my object. However, it does have that little caveat to go along with it. And at some level, it is considered a best practice in the documentation to use loc or iloc where it is where those are appropriate and where that's how you plan on accessing it. But I find that IX is probably how I typically go about accessing information or accessing data via an index. So there's one thing here that's not mentioned, which is an XX method. So it is literally just those two letters, X and then S. That's a great way for being even more explicit about what you're trying to get. So you can pass the label name and then pass the level that you're trying to access, and it will allow you to be very straightforward about the information that you're trying to grab. I talk a little bit about that in my book just because of how straightforward it is, and it's a very kind of it's more of like a self-documenting way of writing code than using something that's a little bit opaque like IX unless you really know what's going on. And so, like I said, if you're dealing with pandas in an interactive shell, and you don't have other people maybe relying on your code or reading your code to try to understand what's going on, by all means use IX, and like I said, that's what I use. But there are other ways of doing that that maybe get the job done without being as complex. So wanted to talk now a little bit about special index types. So there's two index types here that I'm going to talk about. One is a datetime index. So that is basically an index through a range of dates. And then the other one I'll talk about here in a second, which is what I've already shown a little bit, is a hierarchical index. So a datetime index is very simple, and I show basically creating it right here, where it's a start and an end and a frequency. Now, to be completely honest, that's not the whole story of datetime indexes. When you're dealing with the datetime index, you can do a lot more that I'm not going to talk about here. For instance, you can actually deal with periods in the datetime index. So instead of dealing with individual days or some level of frequency, you can deal with periods, which can be useful. I don't find myself using them as often as I do just dealing with a straight datetime index. So a datetime index is instantiated in a very simple manner, like I've shown here. You can do a start and an end and a frequency. There's a lot of frequencies. I would refer you to the documentation if you want to know what frequencies are available. If you suspect it's there, it probably is. And I believe, I'm not sure how deep of resolution it goes, but I want to say it might go down to the nanosecond at this point. I'm not sure, but I'd imagine it probably goes as far down as you would want and as would be useful. So they're created in that manner. There's a couple different ways you can create them. So this is kind of the base level you can create them. You can create them via maybe like a start, a frequency, and a number of periods. That's another option. But they give you a kind of a very simple, very quick way of creating some range of a time frequency that you want and using that as the object. And so you might be thinking, well, why would I go through the trouble of creating of using a datetime index? And so I think this bottom section where I'm grouping by the month hopefully kind of shows its power in a very maybe short, unassuming way, I guess. So if you want to group by month, right, so you can very simply just pass it the month part, because the datetime index is going to retain all the information about a date time that you would expect. So you can just call the index.year, the index.month, and you will get those particular values, which is incredibly useful for grouping up and going to, less resolution of your time series and then performing some operations. And so what that allows you to do kind of going forward is with a series, you can actually select like individual dates or individual parts of your date time, and I guess the best way to put it is it allows for working with dates in a very quick manner, right? So here, instead of doing something more exotic, like trying to basically get a list of every place the index is January, I can pass it a truncated date string, and it will get only the January values, which is very useful. The other thing I want to talk a little bit about here, which I alluded to earlier, was the ability to pass slices of dates. So here we can pass basically the 1st through the 31st, and again, that's only going to return January. And then, so I see a question whether or not location can be used to select a slice when using a time series index. I believe it can. I'd have to try it explicitly, but I'm almost positive it works with the IX method. So I believe it would probably work with the location method as well. So slicing is very useful, especially when you're dealing with dates. So resampling is also super important or super useful. So resampling here, you can kind of go up and down resolutions. So you can resample to month, which is if I have daily data, I'm going to, go to less resolution, and there's an how argument that accepts a sum, accepts a how argument, and then you can choose how you want to aggregate that. Here I'm passing it a string, and Pandas is smart enough behind the scenes to understand that some string corresponds to a sum function, and then it'll carry that out. And like I mentioned here, it's effectively a group by. The other thing you can do with resampling is you can go down resolutions, which is really a neat feature. So I have daily data here, and I actually want to go to 12-hour data. So that's going to double my date series, right? Because I had, let's say I had 31 days for January. Now I have two dates and times within each day. And then it also takes a fill method, which goes into how you could fill those objects. Without specifying that, or without a way that Pandas would know how to specify that information, it has to choose some manner by which it fills up the NAs. And actually, you can have it not fill up the NAs if you want to have NAs, or you can do something like pad, which will actually duplicate the data and pad it within a day. I would refer you to the specific documentation to how the different methods you can use to fill your resampled data, but it is there and is available, and it's a great kind of reverse group by, so to speak. The next thing I want to talk about a little bit is the Multilndex. So this is not super new to Pandas, but it is fairly new, and it is extremely powerful in my opinion. So there are two kind of things I want to talk about right off the start, which are labels and levels. I've talked a little bit about levels already, so I'm not going to spend a lot of time there, but as you can see, the second chunk where I call multi.levels, you basically get the 0 and the 1, which is the first level, which is A everywhere, and then the second level, which is A and then B. Labels, conversely, is going to actually be like the integers that are associated with the kind of uniqueness of the multi-index. So here we have 0, 0, which is going to correspond to A and A, and then because in the second index is A and then B, you're going to get a 0 and a 1. So that is really just useful in kind of when you're dealing with multi-indexes, because they can be a little bit more, they need a little bit more information about what you're working with. So those are kind of specialties, so to speak, when you're thinking about multi-indexes. So one thing to kind of walk through real quick, though, is not much actually, or some stuff does change, but not as much changes as you would expect when you're dealing with a multi-index. So here I use the same multi-index you saw created from the last slide. And just, I guess I'm getting a little bit ahead of myself, so I apologize. When you create a multi-index, you can create that standalone, much in the same way I created the DatetimeIndex in a standalone manner. But you can basically pass it like a from tuples, and there's a couple other ways you can create a multi-index. But here I'm just passing some tuples to create the multi-index. And so I use that in this next slide, where I am creating a very simple data frame. So here it's dead simple. It probably would even be better served as a series because it's a single row of data. But you can see that you can use the IX method. And so here's actually probably where my tendencies come out a little bit, is I'm using the IX method to select the data where another means may have been better or may have been more explicit. However, the IX method actually works maybe a little bit different than in a hierarchical situation than it would normally. So here I'm passing A as the first argument and then B as the second argument, which, if you remember from the first couple of slides when working with panels, that the second method or the second argument dealt with series, it dealt with the individual items of the data frame, not the data frame itself. And then so, again, this is kind of this XS method, which is, again, in my opinion, a very kind of explicit way of telling people what you're doing with your data. It's maybe not as robust and as automatic, but what it does do is it says very clearly, this is what I'm interested in doing. So I had a question come in, which is a little aside, but it's my kind of, I think it's certainly important for Python and Pandas in general, is which is easier to learn, BPython and IPython. So if you actually look, and so just to be clear, this is we're kind of moving on to the next section. So if you look at BPython or IPython, basically I use IPython. BPython is great. It's got a lot of information, but IPython is actually what I used when I was writing the code for this slides. And even though I don't show the different prompts it has, do be aware that, or I guess I would use IPython, especially if you're dealing with interactive work or IPython Notebook. If you're not familiar with that, I would highly recommend. So kind of besides that aside, do you want to talk really quickly, and I want to try to get to some questions, about manipulating data with indexes. So this is a very small example, but I just want to show that it certainly is possible to overwrite data via index access. So quite often you'll see people pass in a masked array of like trues and falses and then update data that way. That works. However, when you're dealing with indexes, that's not going to work as well because you're not comparing a column values. You have the actual values. The values would you be comparing with are in the index, not in the columns. So this is just a quick hitter to kind of show what's available in terms of updating the data. The second thing I want to kind of talk through is reshaping data. So unstack is incredibly valuable, especially if you're dealing with plotting. So if I was going to try to plot this data file, say the CSV to the right, without doing anything to it, it would be a very bizarre looking plot, because the plot function, and so one thing I don't talk about here, but I do talk about in my book a little bit, is plotting with pandas, which it does a really nice job of quickly allowing you to visualize the data that you're working with. But what that means a lot for indexes is you potentially need to reshape your data or get it into another format. So unstacking is a really quick-hitting way to do that. So here we see that level argument again. And if I have df, and I just read it into my data CSV file directly in, I then have data and products, and I had set those as indexes. I would have data and products as indexes, and then I could unstack those to create a hierarchical index of columns. And kind of like I said earlier, I don't get too much use out of multi-indexes and columns. I don't use them that often. Not to say they're maybe not useful or not worthwhile, but I just don't find myself using them that often. But unstack is a great way to kind of reshape your data as needed. And so a couple of the other things kind of as we wrap up here is, so and some of the things that I guess I didn't cover more because of time, but to be aware of, are joining, ways of joining. So you can quite often use the merge function to join data frames, but what you may want to do is use the join method of a data frame and join on indexes. Or one thing that I wasn't aware you could do for the longest time, and it's a bit embarrassing to reveal this, is that I didn't know how to join series for a long time. And you actually can concatenate those on the index to join series together. Thankfully I'm past that now, but so joining is another way you're going to see indexes pop up a lot. And the first kind of inclination to do when you're trying to manipulate an object with an index is to get rid of the index. However, if you do take if you do use some of the more specialized joining methods or concatenation methods with an index, then you will then you can not go through the extra steps to recreate something. So so that's the end of the slides. I did want to try to touch on a couple of other questions. So one of the questions that came through is speed affected by using the IX accessor method instead of loc and iloc? I'm not sure, honestly, if it's affected in a manner that you would notice. One thing, though, to be aware of in terms of speed, especially to do with indexes, is basically sortedness of the index. So you can kind of, this is again very similar to those of you who are familiar with a database like Postgres. If you have indexes that are sorted and the sortedness of those indexes is known, different algorithms can be used to access objects. So there is a sort index method of a data frame that will allow you to resort your indexes. And if you do that and you kind of write your code in a way that maintains the sortedness of that, when you try to access objects, it will be faster because Pandas is optimized in such a manner that if it knows what you're dealing with is sorted, it will access it quicker. So that is one kind of performance thing to be aware of when you're considering accessing objects. And if you notice there are some performance issues when doing that, thinking about if you have a sorted index is important. Another thing I don't talk too much about is uniqueness, or I didn't talk too much about, is uniqueness of indexes. So uniqueness of index isn't like explicitly required when you're adding indexes to objects, but quite often you will get errors, and you'll get them very quickly if you're trying to deal with indexes that aren't unique. So all of the examples here I talked about had a combination of, if I was dealing with a hierarchical array, or excuse me, a hierarchical index, all of the indexes would have uniqueness, at least in combination of the 0th level and the 1st level. So you'll want to be careful and make sure that you're dealing with, with basically, you'll want to make sure you're dealing with situations where that's the case. And you can actually check for integrity as that comes through when you're creating indexed objects. There's, for instance, the set index method. I didn't talk about this particular argument, but it can check for integrity and check for uniqueness as you're setting that and throw an error. It's faster if you don't, but it certainly is something to be aware of. Let's see. So here's a question. So are the dimensions of data frames in a panel independent, or does Pandas add in ANs until all the data frames are equivalent in size to the largest data frame? It's going to basically, and your intuition is kind of correct here, and that you're going to kind of keep the maximum dimensions of what you're dealing with, and it's going to add the NAN. Now, you can drop NANs very easily. However, your intuition is correct, so you're going to kind of create everything, or you're going to have NANs in situations where the data may have been missing. Let's see, looking at a couple more questions. Here's a question. What are the downsides and limitations of DatetimeIndex? Does it work well with very sparse data? I can't speak a lot. I wouldn't want to lead you astray of dealing with sparse data and how that affects performance of your data frame. What I can say, though, in terms of like downsides and limitations, is that I guess I haven't found situations where it is very much a downside to have a very explicit date-time index. All the kind of the metadata you have is very useful, and so I think maybe the only limitation I see is there is some upfront cost in creating that. But in general, the extra methods that you have, because it's a datetime index, quite often trump that initial setup time. Okay. So let's see. Let's see. So set index, there's another question. Set index lets you go from a non-hierarchical data frame to one that takes column names and uses unfortunately, I think there's a word missing in the question. I'm not sure I understand it. So here's a final question. Does adding NAN to mitigate missing data affect memory and performance when working with that data frame or panel? So this is another question where I'm not confident enough in knowledge of the specifics internal of memory management that I would want to lead you astray. Pandas is extremely quick. It's very fast. And so, yeah, so again, I certainly wouldn't want to lead anybody astray. But again, if you're concerned about NANs, I would look into Python or Pandas' ability to handle NANs and either dropping them or replacing them with values that you would want. So I think at this point, that is kind of all the questions that we have come in.
Great. Alrighty, folks. With that, we're going to say a really big thank you to you, Trent, for presenting a fascinating webcast for us all today and for sharing all your knowledge and expertise with us.
Yeah, happy to.
Folks that attended our webcast today, we thank you for attending and hope you've benefited from it. And a big thank you to those of you that sent in your questions, because having your questions really adds just so much to our events, so we thank you for that. We would like to let you all know that if you didn't open your group chat, please do open it. There's some information in there to save you some money today as a thank you for attending the event. O'Reilly has a special offer for you on Trent's book, Instant Data Intensive Apps with Pandas How-to. We'll save you 50% on the ebook, and again, that's a thank you for attending the webcast today, and we do hope you take advantage of it because there's a lot of good information in that book that can really help you with your day-to-day. Thank you again, Trent. Thank you to you all for attending. This will conclude today's webcast. Goodbye, everybody.